Hey everyone, we will just wait a few more minutes for everyone to join in. Feel free to say hello in the chat and where are you from. Happy to get to know you. My name is Philip. I'm from Germany. Or Australia, 3 a.m. Early bird, I would say.
Or maybe they're a late person like me.
Okay, I think we can start. Maybe a few more people will join in. It won't be an issue since we are starting a shorter introduction. So welcome to our first workshop of our hopefully long workshop series about using Hugging Face transformers with Amazon SageMaker. The first workshop will be oriented about training a Hugging Face transformer model on Amazon SageMaker and directly deploying it afterwards to SageMaker as an SageMaker endpoint for running some predictions. Today, joining myself is Nate and Merve from our developer advocate team, and then Mathieu from AWS. He is a startup solution architect and will tell you a bit more about Amazon SageMaker and what SageMaker is. Before we get ready, here are a few links for you to reach out to us. So we have a new released Discord channel where you can join. There's a new channel called SageMaker NLP where you can ask questions during the workshop or after the workshop if you're running some of the examples at home or at work. And then we have a forum where you can also ask questions. There's a dedicated SageMaker channel, and then you can find everything we are going to show today on GitHub. And yeah, these links will be shared again in the chat so you can access them. And then Mathieu, the stage is yours.
Okay, hello everyone. Thank you for joining. I will share my screen and pass through a couple of slides to present the AWS ML vision. So the vision of AWS is to make machine learning accessible for all the customer. If you are developer, data scientist, or business user, we should have a solution to achieve your goal. So we signed a strong partnership with Hugging Face. Today, as you know, Hugging Face is like the most popular open source company providing state-of-the-art NLP technology. And on the other end, we have Amazon SageMaker that offer a high-performance resource to train and use your NLP model. So the AWS ML stack is composed of 3 layers. So at the bottom one, you have the infrastructure layer where we can provide you some GPU, some dedicated chip for the inference, but also some deep learning container that include TensorFlow, PyTorch, Apache, and newly Hugging Face. On top of that, you have the Amazon SageMaker. We will do a deep dive on that one that help data scientists to focus on the science part and let the heavy lifting of managing the infrastructure to AWS. And on top of that breaks, you have the IML services where it has really service where you don't need to have any knowledge in science, but you can still use it to power your website or application. So introducing the new Hugging Face experience in SageMaker. So we have created with Hugging Face what we call a deep learning container, a DLC, that will work both for training and inference and for the 2 frameworks, PyTorch and TensorFlow. Hugging Face estimator is like directly include in the SageMaker SDK that will allow you to really easily launch your script in a scalable way and also cost-effectively way without worry about Docker because you just provide the script and we run it for you. We have a comprehensive gallery of examples that you can read and inspire you to create a new application with Hugging Face and SageMaker. And at least at the end, we have the support. So it's maintained, it's supported by AWS. So if you have already a subscription to the AWS support, we can help you on that one. So what are the benefits for using Hugging Face on SageMaker? First is like cost effective because we optimize SageMaker to scale for the performance and the efficiency at the reduced cost. And you can leverage or spare capacity of instances that we call spot instance to go further and reduce the cost for non-critical workload. We are MLOps ready, so you have an automated metadata persistence. You can search the SageMaker meta store. You can log the log will be included in CloudWatch, and you can monitor, debug, and profile your model and create experiments. It's scalable, so you can run a cluster of GPU with an efficient data parallel and model parallel distribution provided by SageMaker and the ability to launch several jobs at the same time. And at AWS, security is job zero, so we raise the bar about the security, and we provide a mechanism to fully encrypt your workload at rest and in transit, and you can leverage the VPC connectivity and the fine-grained access with IAM. So the benefit of the Hugging Face DLC is really a top quality. It's directly supported by Hugging Face and AWS. It has been tested and included in the latest Hugging Face and innovation, AWS innovation. It will remove the heavy lifting of creating an easier self-managed. You don't have to provide Docker and do the custom Docker integration with SageMaker. Everything has been done for you for more ease to use. So how it works in a nutshell. So you build your script at the beginning inside a notebook, and you can leverage the notebook or the SageMaker Studio or your own IDE. Doesn't matter. And so when you have your script, you will pass it to the SageMaker training container, the DLC, and that one will provide a way to train your model on GPU or CPU as you requested. And from there, you can fine-tune and manage your experiment. When you have your model that has been built, you can deploy using a SageMaker hosting platform. And if you use that, you will have an automatic scale from your model endpoints. But you can also download it from the model, download it from S3 and self-manage the deployment. And so now it's the moment that you get your hand dirty. And so you can go to that URL, dashboard.eventengine.run, and we provide the hash code in that page. And I will work through with you through the step to access your AWS environment to try to follow us on that journey for training and deploying a model. So I will do it with you. Let me just grab the URL up. And the hash code. So I will send both of them in the chat so you can follow me. Sorry about that. Okay, thanks, Philippe. And after, you can go through the email one-time password. So you put here your email, send the passcode. I will receive it in a couple of seconds. Oops. Okay, receive it. And you land to the dashboard. Here you have a link to access the AWS console. You click on it and you click Open the AWS console. From here, you can just accept everything and go to SageMaker. There is the SageMaker console, and today we will use the notebooks on the left menu and go to notebook instance. You will see that we have 4 notebooks already started with the workshop pre-installed on those, and you have the red, yellow, blue, and green. So you can pick one of them and click the Open Jupyter. From there, you already have the repository that Philippe shared at the beginning of the presentation. And so you can click the workshop one, get started with Amazon SageMaker. Here you have the free notebook. We will do the lab one. And just take care that it was not like running here or that you don't have a running notebook on that tab. If it's the case, it's just because someone else took that instances. And so you can go back and choose another one here. So I will just open that one. And as you can see, if I refresh it there, so that it's running. So if you have a running instance, please just take another one in the SageMaker one. And so now you are in the notebook. And so I will end up to Nate to go through that notebook.
Awesome. Thank you, Matthew. I'm going to share my screen. Beautiful. Is this coming through?
Yes.
Awesome.
Perfect.
Okay, great. So today, now what we're going to do is we're going to train a Hugging Face transformer for multi-class classification, text classification. What we're going to do is train a model that can understand emotion. So given input text, so for example, I like you, I love you, we're going to predict over 6 different classes of emotion. In this case, you can see that it predicted love. These are the other available classes. And the dataset we're going to use is the emotion dataset, which is available on Hugging Face's hub. So the first thing you're going to need to do is install any of the required libraries if you don't have them already installed. And so that's Torch, TensorFlow, whichever one you want to choose. Today we'll be using PyTorch. And then SageMaker, transformers, and the datasets library. So first, we're going to import the Hugging Face integration into SageMaker. And then the first thing you always need to do on SageMaker is authenticate. So we're going to set up a SageMaker session. And inside this notebook, what you can do is you can call .get execution role, and that will automatically pull in your authentication. So you don't have to worry about trying to point to a specific role or anything like that. So we're going to run this cell. And we're going to see that this is our ARN role. This is the S3 bucket that we're going to use, and this is the region that we're in. Now, the first thing that we're going to do is basically pull down a data set, process it locally, and then we're going to push it up to that S3 bucket so that we can use that for our training. So like I said, we're going to be using the emotion dataset, which is a data set that consists of 16,000 training examples, 2,000 validation examples, and 2,000 testing examples. Today, we're just going to be using the training and testing sets. This is a very simple example just to get your hands dirty. So first things first, we're going to define our tokenizer name. If you're familiar with Hugging Face, you know that we have these objects that you then call .from pre-trained on. And this is a reference to a model ID that's on our hub. So you can actually find any of these models on our hub just by searching for this. Now, we're going to be using the Distilbert base uncased model. So it's not going to use case. It's not going to be case sensitive. And this Distilbert model is actually a little bit smaller, so it trains a little bit faster. I found that it's something that you see a lot in enterprise, in production, because it is a faster variant of BERT. Now, again, we're going to define the dataset name, which is emotion. And then here we're going to lay out the S3 prefix. So this is going to be the location on our S3 bucket that we saw earlier, that our data that we're about to process here locally in this notebook instance is going to be saved to when we push it up. So again, we're going to process it locally in this notebook instance, on this compute, and then we're going to push it up to S3. And then from S3, we're going to pull down that data from S3 on our GPU instance later when we go to train, so that we can use that for training. Now, the benefit to doing this where we're processing it locally and then pushing it up is that when you go to train, you're not going to have to wait for your data to process on that instance, on that expensive GPU instance. So we're going to process it once on the CPU instance that I've got here, and then we don't have to waste time and subsequently money on our GPU instance to process the data. So here we're going to initialize our tokenizer. So we're going to use Hugging Face's auto tokenizer, which is basically asking for a model ID from our hub, and it'll automatically pick the right tokenizer to instantiate. Now, if you're not familiar, the tokenizer is something that's used to take raw text, so something like this, a string, and turn it into the input IDs that your model is looking for. Beautiful. So we're going to instantiate that, and then we're going to define a function to tokenize our data. And that's basically going to take a batch of data from our data set. In this case, the field name is text, and we're going to pad it, and we're going to truncate any sequences that are longer than the tokenizer's max length parameter. Now, This function here is going to actually load the data set. So we'll load it, and we're going to specify that we only want to load the train and test splits. Then we're going to take that function that we wrote, and we're going to map it across the data set. So we're going to map it both across the train data set and the test data set. And if you choose this batched argument, it's actually significantly faster. So that's what we do here. Next, we're going to just rename some columns. The reason why you do this actually is because the data set, the raw data set that is on Hugging Face comes with this field called label. But when you pass batches of data into your model to make predictions later, the Hugging Face model, it's expecting a field called labels. So if we actually change the field here, we can just unpack the dictionary into the model when we go to make predictions, as opposed to manually picking out the keys and passing it to the model one by one. So that's kind of like a little tip. Now, here comes the part where we actually upload that data. So we're going to take the data set that we just processed, these train and test data sets that we just processed, and we're going to use the file system, the S3 file system helper from the datasets library to save that up to that file system. So we're going to take the train data set and we're going to save it to that, that default bucket that we had at that prefix that we defined earlier. And we're going to split it up by train and test. So this is going to save just the processed file up to S3. Or files rather, because we have two. Beautiful. Now we are ready to fine tune and start our SageMaker training job. So what we're going to basically do is we're going to take that Distilbert based on case model, which is a model that has a general understanding of language, and we're going to fine tune it for our specific task. So what we can do is, well, I guess I should go over some of this here. The idea is that you're going to define a training script. And if you notice in our notebook, there is a training script that we'll take a look at here in a second. And you're going to point to that. So you're going to have an estimator here, and you're going to point to that training script. You're going to tell it where it lives. So you're going to tell it that it lives in this scripts directory, which you'll notice it does. And we're going to define our instance type. We're going to define the transformers version, the PyTorch version we want to use. And then we can define any hyperparameters that we might want to use as well. These hyperparameters get passed in, if you're familiar with SageMaker, they get passed in as flags to your script. So you need to define an argument parser. So I'll go over the script in just a second. It'll give us a chance to start the job so that we can, while we're waiting for it to spin up and train, we can talk about the script a little bit more. So here I'm going to define those hyperparameters. I'm going to import the Hugging Face integration here. The estimator, and we're going to define our estimator here, and then we're going to start training. So we just I ran this cell and we just spun up the job, and it's going to start training. So let's go back and take a look at and break down what's going on here. So like I said, these hyperparameters that you can define, they get passed in as arguments or flags to your script. And we wrote this script up here, which you can see lives in the scripts directory, and it's called train.py, which is why we specified that here. It's in the scripts directory called train.py. And the top of our script, we're going to define an argument parser. So using argparse, we're going to define an argument parser. These are the hyperparameters that we would like to have. In this case, it's the number of epochs for training, the training batch size, the eval batch size. So how many examples to feed your model during training and also during evaluation. The number of warm-up steps, the model ID. The model ID here is going to be our Distilbert based on case. The learning rate you'd like to use, and whether you'd like to use 16-bit precision for training. Now, in addition to that, we're going to define other flags. And these flags are actually just going to be overridden by your environment variables. When you run a SageMaker job, it's going to pass in these environment variables. And specifically, there's going to be the output directory, data directory. So that's exactly where you're going to want to save any output data. Your model directory, which is where you're going to want to save your model. The the number of GPUs that are on your machine, how many it's configured to use, and the training and testing directories. So this is where your training and testing data came in. And the reason why we're going to actually define these as flags here is because when you're training locally, if you want to run this script outside of SageMaker for development purposes, maybe on your CPU, just with like a dummy model, just to make sure it works. This way you can actually still do that. So you can just pass these flags in when you're running it locally, and then when you go run it on SageMaker, it's going to just work seamlessly, and you don't have to change your code at all. Beautiful. We're going to then, after you define these arguments, you can parse the args. So this is going to parse these from the standard in. We're going to define a logger, which will help us log things to SageMaker so we can keep an eye on what's going on. After that, we're going to load our data from the disk. So, we pushed it up to S3 earlier, and then when we start a job, we said, this is the S3 bucket that we want to use for training and testing, and we pulled that down. SageMaker is going to pull that down, and we're just going to reference that using this training directory and this test directory. So we'll load those in, and now we have our training and testing data sets. After that, we're going to define a metric and a compute metrics function. This metric comes from the Hugging Face datasets package. So in this case, we're going to use accuracy. And because we're going to use the Hugging Face trainer, the transformers trainer, we are going to define this compute metrics function, which is going to take in a prediction object, which is going to include the raw predictions as well as the labels. So these are going to be like probability distribution that we're then going to get a choice from. So in this case, we have 6 classes. So we're going to choose, which one did the model predict is the one that the model thinks is the right prediction. And then we're going to use that metric that we defined to compute the actual accuracy across that batch. And this is, this function is how you could define any other metric that you would want to define. So this is where you could do something like, precision, recall, things like that as well. Now, this part right here is actually a little bit of a hot tip. Using the datasets library, we can reference the features within the dataset. So in this case, I'm going to reference that labels feature that we talked about earlier in the train dataset. And we're going to get all the names of the classes. So in this case, we're going to get if we saw earlier, we're going to get these 6 names as a list. And the reason we're going to do that is because we'd like to define the labels in our model so that when we save our model configuration later, it's going to have access. It's going to know what the actual labels are to the model, as opposed to just knowing there's 6 classes. Like we're not just going to predict label 1 or label 4. We're going to actually predict. We're actually going to be able to tell the user what label it was. And you'll see that later when we go to do the prediction endpoint. We'll see that we're actually going to get the label names. So yeah, in this case, the way that the model is actually going to expect this is as a dictionary. So we're going to set up 2 dictionaries, one for doing the string label to the ID, and then one going ID to the label. And both of those actually have to be strings. So that's why you see us casting these indexes to strings. After that, finally, we're good to instantiate our model. So we're going to instantiate our model using that model ID, in this case, Distilbert based on case. We're going to specify the number of labels, which is 6 in our case, and we're going to give it those label to ID and ID to label mappings. We're going to instantiate our tokenizer again, because again, this is running in a separate place. So even though we instantiated it up here in this notebook, it's this script doesn't know about that, right? Because it's running independently. And then we're going to use Hugging Face's training arguments object to define all the extra arguments that we are going to go into our trainer. In this case, this is all sorts of things like which learning rate scheduler you'd like to use, the warm-up steps for that, for your learning rate, weight decay, all sorts of things like that. After that, we instantiate a Hugging Face transformers trainer, passing it the training arguments, the model that we defined, or rather the model that we instantiated, the untrained model, our compute metrics function, our trained data set, and our evaluation data set, which will end up being turned into PyTorch data loaders that we'll iterate over during training, and the tokenizer that we want to use to process the text. Finally, we're going to train and then evaluate. And we're going to print out some stuff at the end so that you can see it. And at the very end, we're going to just save the model to that SageMaker model directory, which is how we're going to be able to get that model later. So like I said earlier, when we save this model, it's actually going to save our labels as well that we were able to specify here. So we'll actually get the labels in the end for making predictions. Now let's check on where our training is. It looks like it's just starting training. At the same time, just so that I don't forget, I'm just going to run these last few cells. They're not going to run until that one finishes, but I just want to make sure that while we're chatting here, that can be running in the background. Now, this visual helps us understand a little bit more about what's happening. We're interfacing with AWS through the SageMaker SDK, specifically the Hugging Face integration here. And what's going to happen is we're going to pull in a pre-trained model from Hugging Face's hub at hf.co. And we're also going to pull in the data set that we pushed up to our S3 bucket earlier, both the training and testing data sets. The instance that we chose to train on is going to be configured using the Hugging Face training container. So you don't have to mess with Docker or anything like that. We're going to do training on that data set using the Hugging Face's using Hugging Face's trainer, and it's going to save our fine-tuned model up to another bucket. So we have that now at an S3 bucket. So we have things like the model, the save model, the model configuration. You can get things like the logs. You can pull those down later. Then from there, once training is completed, we're going to take that model that we pushed up to this bucket right here. We're going to pull that down into another instance, but this time for an inference instance, and reload it. And then we're going to be able to use it anywhere. So we can make predictions right on this instance. And you can do that on the GPU, you can do it on CPU. You can do this for large models, small models, anything you want. So beautiful. And we can see here that we're training. You can see some things being spit out. We just finished our first epic here, and we'll continue to get some information. Beautiful. So while we're waiting for that, is there any questions that I can answer?
Yeah, maybe Emilio asked, can you please explain save the model to S3 uses the environment variable to make sure checkpointing works? Maybe I can pick that up again, Emilio. So what Nate has shown, like in the last step of the training script, basically with the trainer.save and providing the environment variable, will then Hugging Face transformers, the trainer will save the model to the directory, which will be uploaded to S3 after your training is done. So after all epoch evaluation, everything is run through, SageMaker will pick everything up in the directory, upload it to the S3 bucket we have created earlier within the session, and then you can access it directly from S3. But if you are like interested in like using spot instances and checkpointing to like continue training or like train on a model, stop, and then continue training on the same model, there's another lab in the workshop, the lab 3, which is called spot instances. It includes the same script Nate went through, but it includes also like the configurations you would need to make in the Hugging Face estimator to use checkpointing and spot instances. And for those who don't know what spot instances are, it's like a special, I would say, instance situation on AWS. So AWS has a lot of EC2 instances, and when they are like not used by customer, they can get or can be available into like in the spot instance pool, and these can be like reduced in terms of pricing up to 90%. So you could, for example, start your training with a spot instance. If it's like not really depending, then you have luck and get a spot instance and will save costs during training. But these spot instances can be automatically like stopped. So if a customer wants to use the instance type you're using for spot training and he wants to use it as an on-demand instance, AWS basically will automatically stop your training job and give the instance to the customer. And with checkpointing enabled, SageMaker will still upload basically your current model and the checkpoints to S3, so you could continue training.
Right, beautiful, thank you.
Also, there is another question.
Sure.
How do you troubleshoot diagnose issues before or during the training process? Example, shape issues.
Sure, that's a great question. So my suggestion is always that you're going to be running these things locally or in a SageMaker notebook. So we can actually take this code and run it straight from the SageMaker notebook on CPU. Or you can run it on your laptop, or you can run it on SageMaker, whatever you feel is best for your workflow. But 80% of your time in development is going to be spent debugging and working on making sure your script works before you go to launch a big instance on SageMaker. So my suggestion is that work on these things either locally or up on a SageMaker notebook instance. Play with the model, make sure that you get your script working correctly. And then once you're ready, that's when you can spin up a SageMaker training job to scale up your script. So if you just try to develop and execute training jobs every time you want to run your code, you're probably going to have a bad time developing, because you're not going to be able to get instant feedback. But if you make sure your script works perfectly before, it'll work just the same on SageMaker. So that's what's great. That tends to be kind of the workflow that you see whenever you're using AWS. You want to make sure your stuff works perfectly, and then when you want to scale, that's when you use the training jobs, because it's going to run your code the exact same as it does locally. So if you're having issues with shapes of things, or if you're building something and you want to add a layer to something and you're in development, definitely use something interactive like a SageMaker notebook. Yeah. Any other questions, Merv?
Yeah, there are like a few more, like from Rajiv. I hope I pronounced it correct. Does the trainer function have callbacks similar to Keras, save the best model / plug into TensorBoard, or weights and bias and early stopping parameters?
Sure. Yeah, of course. So yes, the Hugging Face trainer does have callbacks. In fact, the callback that is used for the default logger, which is TensorBoard, is a callback. So you can define your own callbacks and then use them for whatever you want. So if you want to add your own logger for something domain specific or specific to your company, you can do that. If you ask specifically about 1B, so let me show you actually. I believe it's let me show you in the training script. So if you wanted to define that you wanted to use 1B, weights and biases, you could just add a parameter here, a keyword argument here called report to, and you could specify that you would like to report to 1B. And you can find that in the docs for training arguments. You can find that on the Hugging Face Transformers docs. If you search training arguments, you'll see the report _to keyword argument, and that lets you either specify that you want to report to one logger or multiple. So you can actually report to both TensorBoard and weights and biases, which is something that I tend to do, where maybe when you're running it, you want to be able to view or rather when you share your model later on Hugging Face's hub, you can actually share the TensorBoard logs. So I like to share those there. But when I'm personally developing, I like to use weights and biases. But yeah, we have all sorts of different callbacks that have been written by the community. You can find those online, and you can define your own for whatever you want.
And maybe pick up a question from Mike. When you install libraries in a notebook, does those libraries get added to the training and inference container? No. So basically what Nate has done in the first cell is he's installing it into the Jupyter environment where he has done the processing part. If you want to include like additional dependencies like weights and biases or TensorBoard or maybe something special on your side to the training and inference DLC, then you can provide a requirement txt at your source directory level. So in the estimator, we have defined the source dir and the entry point. And if you place a requirement txt in the source dir, in our case, it would be the scripts folder, and add, for example, the weights and bias SDK or TensorBoard or I don't know, Pandas, then you have access during the training for it. And then maybe don't forget, yeah.
I do this estimator finished deploying, so do you mind if I talk about this real quick? So yeah, we finished training, right? And we pushed up the trained model to or the fine-tuned model rather, to another S3 bucket. And then this is how simple it is to deploy. We took that estimator that we just trained, and we're just going to call .deploy. And then we're going to specify the instance that we'd like to, the desired number of instances, and then the instance type that we'd like to deploy to. So we see that we've successfully deployed it, and then we can just pass it this payload here, which is going to be inputs, and then I can specify the text that I'd like to get the prediction for. And in this case, I say I get so nervous before a demo, and we can see that the predicted label is fear. I love using beautiful joy. I feel joyous. So I love using Hugging Face and SageMaker. We got a predicted output of joy. It's a little lower than I would have hoped it would be. But again, this script that we wrote here is for demo purposes. It's a very minimal example. We can play around with the hyperparameters to make this model better. We can train it for longer. I think we only trained it for, we trained it for 1 epoch. So, you're not going to get the best results if you train for 1 epoch, but for the sake of example, we can see all you have to do is just change some of these parameters and you're going to get significantly better results. For this demo, we didn't want to train for too long, so we didn't keep you waiting. Yeah, beautiful. That's the outputs. And then once we're finished, we can actually delete that endpoint by calling predictor.delete endpoint. And I'm just going to leave this up for a minute so that we can make any more predictions if we want to. How about this one? No, I'm just going to delete it. How about we'll just delete it? I won't get too fancy here. I'll just show you that you can delete that. And now we've deleted the instance that was being used for predictions, and it's no longer costing us money. So you can see that, and just look at this 4 lines of code where we spun up a inference endpoint, we made predictions, and then we deleted our endpoint to save money. So if you only need your inference endpoint for a certain amount of time, you're going to want to delete it as soon as you're finished using it, so that you're saving money. And it is really that easy. So beautiful. Okay. Yeah, I'm free to answer as many questions as you'd like now. Phil?
Yeah, I think something we can already tease, because I see a lot of questions, or a few questions coming in asking about more inference-specific use cases. Shayana asked if we can save all predictions to a tabular data, or also Jason asked a bit more about inference in general. So the next workshop series we are going to do will be completely focused about going production. So we have now seen how you can fine-tune your models and easily deploy them with the .deploy method. But I mean, going production is not just deploying inside a Jupyter notebook. There's more to it. If you want to scale up your endpoint with auto-scaling groups, that's also SageMaker is providing. Or if you want to monitor your endpoints, making sure they work, that's basically the focus about the second session, where we will have examples on how you can already deploy fine-tuned models from the Hugging Face Hub as Finbird, for example, to SageMaker to run real-time prediction. And that's exactly what Nate has done. Or also batch transforms. And batch transform jobs are basically what Shayana has asked for, is you provide a JSON line file with 100 or 1,000 of input data, and then run prediction against it, and then you get the whole file out of it back with the predictions. And SageMaker will also again start an instance for running those predictions, and then we'll stop again at the end. And we will share more details about the next workshop series on social media, but all of you who has attended today will also get an automatic invite to the next session.
Beautiful.
And then maybe a few more questions to training. Leandro asked, what hyperparameter do you recommend to fine-tune? Should we train only prediction head or retrain the base model, Distelbert as well?
Right. So you can play around with all these things. I believe training the whole model is actually what we usually do here. But if you want to see some examples of some best practices, you can check out the Transformers repo on GitHub, and we have an examples folder there. And some of the best practices for training scripts are right there. And in fact, I believe when Philip runs his next example, he's actually going to be running straight from that examples directory. So that tends to be a really good place to find these best practices. If you know which parameters to use for what types of tasks, what your learning rate scheduler should be, how much, what kind of learning rate scheduler to use, should you even use one, what to set your learning rate as by default. We try to keep a lot of these default settings and choices. We try to pick the best default settings in this training arguments object here. So if you were to define almost nothing here except for the output directory, we're going to try to choose what we think is probably going to be a good starting point. But yeah, I guess the answer is I guess depends, which is a really which I hate giving that answer, but I think a really great place to get some information on that is the GitHub repo, the Transformers GitHub repo.
Yeah, and also maybe something to note. So on huggingface.co, we have like the models hub, which contains, I think, close to 20,000 community-driven models. And all of them have like those model cards. And model cards usually contain information about how the model was trained and evaluated, so with scores. And a lot of models also contain, like in the training section, which hyperparameter are used for this model. So for example, if you also want to train a model on the emotion data set and want to get like some feedback or experience what other has done, you can go to huggingface.co/models and then search there for a model. And then you can find maybe a different hyperparameter settings people has used before for this kind of task. But I think it's always good to start like small and with like the default settings, and then you can play a bit with the learning rate in the beginning, or like easily increase the epoch size, like from 1 to 3 and then to 5, to see how your model is like learning. And then if you really want to go deep, you can tools like Optuna, Ray to like automatically optimize your models for a specific hyperparameter area.
There is a question on Discord. Mani, I don't know if I'm spelling it right, says a follow-up question on identifying the right instance depending on the memory requirements of the model during inference or general recommendations, he says.
Philip, you want to take that?
Yeah, so for inference, you can firstly select between CPU and GPU instance type. For CPU, what we are going to do behind the scenes is starting like 1 worker per CPU core. So if you have like a CPU instance with 4 CPU cores, you will have 4 different workers which all serve the model, so you have like 4 models in parallel. And then for GPU, since we only have 1 GPU and we like doing not like any special virtualization behind the scene, you will have 1 worker. So I guess the best way to start is really focus on CPU oriented. Okay, which CPU do I want to use? Do I want to use like the new Ice Lakes from Intel or a Cascade Lake from Intel, and then see how big my model is? For example, if I have like a default Distelbert model, which is around 250 to 300 megabytes. I'm not sure exactly what the number is. And you have 4 CPUs, then you know if you have 4 multiplied by 250, and then like add a few additional megabytes in memory to, basically load the input. So I would say like if you have like 1.5 the memory available for the model size should be a good fit. And then depending on the CPU you use, you get different speeds for inference. And the better and the newer the CPU, of course, the better your inference time will be.
There is one more question. What are common issues when running prediction jobs in notebooks? For example, if the deployment faces errors during a prediction task, will we see those errors output stack trace in your running notebook?
Yeah, so maybe Nate, if you can scroll to the where you started the training a bit. There you can see.
This part here.
Yeah, a bit. Yeah, exactly. There you can see everything what's happening inside a container. So that's basically produced inside of the container. In the beginning, you have like some configuration and logs about the environment, and then when you scroll down a bit, you will see a few output logs, and then at the end you also will see the transformer specific like evaluation you are doing, or you see like the progress bars of your training. And if your training runs into an issue, you can directly see it there. And then SageMaker will also, of course, take care that the instance type is stopped. You can look into the error, make your fixes, and then run estimator.fit again.
Okay, Phil, I think it might have been about inference specifically. Can we get these logs for this part here?
Yeah, to get like the inference logs, you would need to go to the SageMaker console again, where Matthias started in the beginning. And then next to notebooks, there's like also an inference tab, and then you can see endpoint. And if you click on endpoint, you should see your deployed model. And then there's a few logs button, which will like point you to the logs. And then you can see basically what's happening inside your endpoint.
Beautiful.
We have another question. How would you keep all these processes reproducible? Can you, for example, deploy the notebook script from a GitHub action?
Right. So I think Phil will actually be showing exactly how to do that later. So great question. You can actually you can specify a Git repo by URL, and you can actually just use that. You could run straight off of that. So yes, you can reproduce the experience based off a GitHub repo. My suggestion would be to keep a careful eye on your requirements when defining a requirements.txt file. Pin or limit the versions that you're going to be using, so that it continues to be reproducible. Because if you leave your requirements open, things might get updated and things might break later down the line, because that's the beauty of open source. Things are always changing. So just make sure that you're pinning your requirements, and you should be all good. Phil, you want to say anything else on that?
Yeah, so in addition to like make things reproducible, SageMaker has something called SageMaker Pipeline, which is a service introduced, reInvent last year, which helps you building end-to-end pipeline like automatically. And also SageMaker has something called SageMaker Experiments, which is pretty similar to weights and biases, where you can like log all of your hyperparameters. So you can add SageMaker Experiments to your training, and then it will create like different runs of your fine-tuning script, and it will also save like the metrics output. So you have like all of your hyperparameter and the output, what it has achieved. And this will be all tracked inside the SageMaker platform. So you can always take a look at the different runs you will run. Or if you don't want to use SageMaker, you of course can use weights and biases or TensorFlow to log your hyperparameters, and then like use GitHub Actions or any other CI tool to like automatically start those training scripts. So for example, if you don't want to start the training from a notebook instance, you basically could convert what Nate has done to a normal Python script, and then it runs from top to bottom, and this Python script can be executed anywhere you want.
Awesome. Anything else? I don't know where we are on time here too.
Yeah, we have a few more minutes left to answer a few questions.
I'm going to take this opportunity to just call out, please join the Discord. It's going to be a great place for, to see things from the community. So not just for today's event, but also in the future. It's a great place for us to all connect. And it's a really good, solid place for updates and things like that on Hugging Face. So I hope to see you there.
Speaking of Discord, we can pick up a question on Discord from Noah Mane, who asked a question relating to something we answered already earlier. Is there a special technique how we can determine how much of like memory we would need to run our training? So if like a data set for examples and a model with a size of epsilon, can we like, is there any like rule how I can select like the best batch size of GPU to use?
Well, I think what I'm more worried about usually is not CPU memory, but I don't know what what kind of data sets you're working with. So this might be something that's very, it's a bigger problem for you. But a lot of these instances have enough memory. If you're using some of these GPU instances, I don't even have to think about CPU memory. But if you are using a CPU version, you could probably, run smaller scripts and check out what kind of usage you're using, and kind of go from there. And kind of cross-reference that with the different instance types. Or what you could do if you're worried about memory usage on CPU instances, just spin up a few training runs and see if they work. See if they work. That's what I would probably do. Like your script's going to work, so you could run these like 4 lines of code like 5 times across a few different instances and just choose the smallest instance that works, or the cheapest instance that works for you. That's probably a good solution too.
Yeah, and maybe also something to point out. So we have in Hugging Face with the training arguments, we have something called max steps. So you can, for example, define only like 100 max steps, and then the training will stop. So define max steps at hyperparameters, set it to 100, and then you can like fast try different like batch sizes on different instance types, and then if you like found the right fit, you can like go with it. And if you like go onto the SageMaker like dashboard and into the training category and training jobs, there you will find all of the training jobs you run. And SageMaker is also reporting the GPU memory utilization. So you can, if you after you started your training job with on the P3 instance with like batch size of 16, you can go to the SageMaker dashboard into training, into your training job, and scroll down to like the instance metrics utilization, and there you can see how much of your GPU memory is basically used. And if you see, okay, it's like 50% or something, then you can probably like double the size of your batch size. If it's close to 90 to 100, then okay, I'm have like a good batch size for my training data set.
Beautiful. Any other questions, Merv?
There are 2. Is there a way to chain multiple models in a pipeline in SageMaker? First paraphrase the text content, run named entity recognition, and then extract embedding, and then ingest to face.
So in general, yeah, I think Phil probably answered this a little better than me. But my first thought on that is, if you want to chain multiple models together, you could probably deploy a couple of them and then just pass them to each other. But I don't know if that's the best solution. I'll let Phil answer that.
Yeah, I think what Nate said is definitely something you could do, or for example, have a Lambda function and then multiple endpoints behind the scenes. But Matthew, maybe you can say something about the SageMaker pipeline, or I think processor pipeline, where you could do like some kind of ensampling predictions.
Yeah, exactly. So you can do that with the SageMaker processing pipeline, where you chain multiple inference endpoints together.
Okay, maybe to answer one last question from Stefan, how does this compare with Infinity? So maybe for those who are following Hugging Face, last month we released a new service called Hugging Face Infinity, which is a containerized solution for low latency inference for transformer models. And how does it compare? So I would say with SageMaker, you can like easily train and deploy your models, and Infinity uses those models to optimize them like to 1 millisecond latency to run predictions, and then you can like run Infinity on SageMaker as well. So I guess like an optimal process would be use SageMaker to fine-tune your model, easily deploy it to run a few tests, or like build a proof of concept using SageMaker endpoints, And then if you like have really like latency requirements down to like a few milliseconds, you can then go to Infinity, optimize with multiverse for your Infinity container. And then if you really want to run it on SageMaker again, that's okay. Infinity is compatible with SageMaker, so you can get all the benefits of the SageMaker platform with auto scaling and like having this easy endpoint to deploy. And if you want to deploy somewhere else, that's also an option to do.
Beautiful.
Great.
All right, should I pass this off here?
Yes.
Okay, great. I'm going to stop sharing.
So thank you for joining. The session will be, or the recording will be shared afterwards on Discord, and definitely keep an eye on Discord or on our social media platforms. We will share the next workshop soon, and happy to see you there. Bye.